Hi, welcome to question 7 of the 2025 Leaf and Cert Ordinary Level Paper 2. So we'll get stuck in. Question 7 starts off as a probability question. Now parts part 1 and 2 are marked together, so together they're worth 10 marks. So we'll read through, and as always, pause it, give it a go. You might find you might have a good chance of at least trying to achieve the lower mid-partial of the question. So Sean is playing 2 tennis matches. He either wins or loses each match. The probability that he wins the first match is 0.6. So it's better than 0.5, which is 50-50 probability. So he's got a good chance. And the probability that he wins the second match is 0.7, so even better chance. The outcomes of the two matches are independent of each other. So winning the first match doesn't affect the winning of the second, although in reality the psychology of it could play in. But we're going to assume there's no crossover. So use this information, or use the information above to complete the tree diagram below by 1. Writing the probability associated with each branch of the tree diagram into the appropriate box, and working out the probability for each outcome and writing it in the appropriate box in the final column. So there's some missing things here. So they say, first of all, that his chance of winning are 0.6 in the first game, 0.7 in the second game, and they end up with this figure of 0.42, and we're given that figure in the question. So if you kind of think of what's happening here, that's the probability of him winning and winning again. Now, the and in probability means you multiply the probabilities. The or situation is where you add the probabilities. Now, if you added these probabilities, you'd end up getting a number bigger than 1, and probability has to score between 0 and 1. Okay. So 0.7 is close to 1. He's got a fairly good chance. 0.6 is closer to 1 than closer to 0, so he's got a good chance. Now, if you multiply those two numbers, 0.6 by 0.7 is 0.42. Now, what we need to think about next is, and this is where I bring in the answer, okay, the probability of him winning, of losing the second match. If 1 is you will win, take away the 0.7, you're left with 0.3. It's the probability you lose, okay? Now, doing that calculation here for this one, okay, you're going to win and lose. So 0.6 times 0.3 gives you a probability of 0.18. Now, in the whole scenario, it was 0.6 the chance of winning the first match, which means there's a 0.4 chance of losing the first match. Now, he could lose and then win. Now, we know the probability of winning is 0.7. We were told that. So the probability of losing and winning gives me a calculation of 0.4. Now, actually, that's a mistake here. I just fixed that there. It's 0.4 times 0.7, which is 0.28. And that's it. That's the table filled in. Okay, so like a tricky enough question, as long as you kind of maybe try say it in your head, it's win and win. And if you have any understanding of probability, the and or scenario is often the trick to these more complex questions. So if you even said like and means multiply, you have a chance maybe of getting some work of merit. Even just going like the probability is between 0 and 1, if you indicate that, it might be considered enough for work of merit. Taking 0.6 away from 1 to get 0.4 would definitely get you the low partial. Okay, at least that. Right, so the last point there, the next question here, part 3, says, based on the tree diagram, what is the probability that Sean wins at least one match? Now, I've screen grabbed in the tree diagram from the previous part with the answers, okay? And this is a 10B scale, okay? So we look here at the answer. We need to be careful because the question states he wins at least one match. These kind of questions often wreck my head a little bit, okay? But we're saying that if the probability of wins at least one match, he could win both, okay? That's at least one, okay? Or he could win and lose, or he could lose and win, which sound like the same thing, but the order matters, okay? And I often get confused when order matters or it doesn't matter. One of the trickier things I find in probability. Now, I appreciate that writing this out as a big, long formula, it can be tricky. You can do it as 3 little separate calculations. But if we put the numbers in, if he wins, and we said and means multiply, so it's 0.6 in the first match times 0.7 in the second match. That's that. And that's, or he could, and or means add, so that's why we're adding them. Win and lose, okay, so 0.6 by 0.3, okay. Or he could lose and win. If he loses, he doesn't win at least one match. Loses and wins, and that's the 0.28. Okay, so when we put those numbers in, the 0.42, the 0.18 plus the 0.28, that gives me an answer of 0.88. Okay, and that's it. So look, a tricky enough question. The B scale means like your low partial, it's a mid partial. If you have any work of relevance in terms of adding outcomes, you might have a chance of even just multiplying stuff together. Okay, just try something, even if this question is trickier. And I do find these tricky. I think when I was doing this initially, I didn't even think of win-win. I was kind of focused on these two. So my answer was wrong. It was kind of right, but I just wasn't thinking the thing through fully. Okay, which is a problem of mine. Right. So question B, part 1 and 2 are back together. Okay, it's a different scenario. Sarah also plays tennis. Each time that Sarah plays a service game, the probability that she wins is 0.78. So she's serving the ball, has the advantage. Assume that winning each service game is independent. So we're going to make that assumption. Now, what is the probability that Sarah will lose her next service game? That is, that she won't win her next service game. I don't know why they need to clarify that. There's a lot of words here. Make sure you read the question multiple times. That could be maybe even have been more important for part A. Okay. But what's happening here is the probability that it will definitely happen is 1. They're saying the probability she will win is 0.78. It's the difference, okay, is the probability of not winning the service game. And that's 0.22, okay? Now, part 2 says, what is the probability that the first service game that Sarah loses is her third service game? Give your answer correct to 3 decimal places. Now, ultimately, what that is saying is that the probability that Sarah will win and then lose, okay, is 0.78, and it means multiply 0.78, and it means multiply 0.22. So putting it into words and phrasing it I think helps me frame what's happening and makes myself more confident that I'm on the right track. Okay. When I multiply those 3 numbers together, I get a big long decimal, 0.133848. But the question does state they want me to round that to 3 decimal places, so it's the 8 here that matters. The number before it rounds up by 1 because 8 is greater than 5, and I end up with 0.134. Okay, and that's it. So it's a specific scenario, like a kind of common thing they'd ask in ordinary level leaving cert. Now we switch gears and we're looking at more at like geometry, okay, kind of area volume. Okay, so part C, part 1, these are marked separately. Okay, part 1 has a 5-mark scale. A child's football is in the shape of a sphere. Now, the second I see sphere, I have my maths tables open. I'm looking at the formula. Even though, like I know it, I often, think I know it, and in the moment, I just write something down wrong. So double check it, even if you think you know it. Okay, and has a diameter of 18 centimeters. And diameter is not as useful as we'd like. We might want to look for the radius, even just to get the low partial. The question then is, find the volume of this ball. Okay, so I'm looking at the volume of a sphere formula. Question then states, give your answer in centimeters cubed in terms of pi. And we don't need to change units because they're already in centimeters. But this is looking for the radius, okay, which is half the diameter. So half of 18 is 9. So 9 is what I'll input into my formula. Run that through the calculator. Okay, it'll give me an answer in terms of pi. I'm not going to change to a decimal because the question says it wants the answer in terms of pi, just slightly more accurate. And that's it. Okay. Now, the part 2 says an adult's football is in the shape of a sphere and has a volume of 524.6 centimeter cubed. Work out the radius of the adult's football. Give your answer correct to 1 decimal place. So this isn't tricky. It's just normally we're given the radius and we find the volume. The volume is on the left. The radius is kind of trapped in here. What we're going to do is we know the volume, okay? We know we know what pi is. It's in the stored in the calculator, okay? All we don't know, the only unknown here is the r. So we need to manipulate this equation in order to like move everything away from r. Now the first thing I'll do, I'm doing two things. If this is 3 is divided on the right, it'll be multiplied on the left. This 4 is multiplied on the right, it'll be divided on the left. So they just swap over going across. I've kind of taken a few liberties there in terms of the algebra. Okay. Now the next thing I want to do is I'm going to move the pi over. Pi is multiplied on the right. Okay, it'll be divided when it moves over to the left. When you move something across an equal, it changes into the opposite operator. Okay, and that's slightly different than how it was presented to me growing up, and I find it more helpful for me to think like that. Now, this cube, okay, if I move a cube across, it turns into its opposite, which is a cube root. And cube roots everything on the far side. Now, this is a calculator job. Okay, when I put that through the calculator, I got 10.899. Question does state it wants it rounded to one decimal place. Okay, so the 9 here is what matters. It rounds the number before it up by 1, which is 10.9. We should always include our units, centimeters. Okay, now part D is a 5 marker. Actually, just to point out that the part 2 there was a D scale, so 10 good marks for that, even for getting up to the low partial, for kind of making that leap. That it's the same formula, we just know something different within it. And then once you get to this statement here, you're like, you're probably at the mid partial. Okay. Now, D says the expected goals, and they're using, for some reason, the letters X and capital G, is a method used to measure the probability that a particular type of shot will result in a goal. During a game, a team had 15 shots on goals. The statistician gave each shot a probability of resulting in a goal, as shown in the table below. I don't fully understand that scenario, but whatever. Then it says in the table, probability of resulting in a goal, 10%, the number of shots was 6, 20% the number of shots is 5, 40% the number of shots is 3, 70% the number of shots is 1. And I don't understand what these shots are. Use information in the table to work out the expected goals of the team in this game. That is the expected value of the number of goals that would be scored from these 15 shots. Okay. Now, I'm going to make up a little table myself. Okay. So the probability of something happening, well, 10% is the same thing as 10 over 100, which is 0.1. So the probability, they're giving us percentage probability. We just want the probability, which is 0.1. So 20% is 20 over 100 is 0.2, 40 over 100, 0.4, 70 over 100, 0.7. Now they're telling me the number of shots, so the expected value is what's happening here. Okay, you're going to multiply those two things together. 0.1 times 6 gives me an expected goals of 0.6. The 0.2 by 5 gives me 1. 0.4 times 3 gives me 1.2. 0.7 times 1 gives me 0.7. Now to get the expected goals, we just add those numbers together. We add this column, okay, and that gives me an answer of 3.5. Now I've always struggled with expected value as well. I was just remembering there is a kind of formula. It's the probability by the data, and then add them all together. That's effectively what the formula says. Okay, so it's what I've done, but I just haven't actually put the formula in there. And that probably is, just look at the marking scheme. Actually, it might be worth just dragging this across for just 1 second. That's the expected value formula, which in hindsight, I should have had in the notes there. Okay, I just kind of did it in a more, I won't say crude, but in a more organized fashion, okay, with the table. Right, that's the end of question 7. As always, if you want a copy of these notes, send an email to shanetry@gmail.com. Like and subscribe to get access to more playlists. Best of luck.